I believe also the schedule is already being sent to the participant and the e-learning. Uh, yeah, and the e-learning already have to the material ready, and you can download the material in the e-learning platform. The module one have three sessions. The first sessions will deliver by Prof. Dr. Syamsidik, and then we will have a break, and then the second session by Prof. Anawat, and then we will have the lunch break, and then the session three by Prof. Syamsidik again after the lunch break, and then at the end we have a discussion. At the discussion, we will have two groups in two breakout room, and then we have the evaluation of day one. So please, without further ado, I would like to welcome Prof. Syamsidik to deliver his talk.
Thank you, Dr. Haikal, Azif Haridi. Very good morning, everyone. Have a good noon. Someone or several person in Japan. Thank you a lot for having me in this training. So, okay, okay, that's share already. Okay. I hope that you can see the screen uh, on your computer or in this room. So the title of the module one would be disaster risk reduction overview in the context of tsunami in Indonesia and in Japan. So we divide this session into three sessions, this model into three sessions. So first session will be from me. I will talk about disaster risk and global frameworks. Then we will have Professor Anawat Suppasri from IRIDeS of Tohoku University. Um, So he will talk about preparedness and mitigation. And later on, after lunch break, we will continue with the session three with practical examples of tsunami risk reductions. Um, yeah, so I'm going to have rather shorter um, presentation and discussion because we are, I think, a bit late, about 20 minutes from the schedules. So I will end my session exactly at 11 probably. So to allow Professor Anwar Supasi to prepare his session on time. Not sure how to use this. Is it this? This? Oh, uh, all right. So the outline of this session, all three sessions actually. So we will have disaster risk and global frameworks, and then second one, preparedness and mitigation in the context of tsunami, of course, and then practical example of tsunami risk reduction. Um, the objective of this module, we expect that all of us, we learn about the development of disaster management concept. So probably some of you are very familiar with the concept of disaster management, but please bear in mind that probably some of us also not that familiar with the concept. So let think this as a review on what we have learned so far about disaster management. And then we will understand, we expect that we can understand the concept of disaster risk management and to review measures on disaster mitigation and disaster preparedness. Um, my side, I will probably a rather general than technical part of the content. Professor Anwar Supasri, I guess he will deliver a more technical and a more detailed explanation on the tsunami itself and tsunami risk reductions from the perspective of some of them is from perspective of Great East Japan and tsunami. I think someone chat. I'm not sure if you can hear. Okay. Okay. Bu Fitri is okay. Right. So now, um, the expected outputs after we attend and participate in this session, we expect that all of us will understand the change in the frameworks of disaster management from time to time. And then we also can elaborate our country context in disaster management. So all of you in this room are from Indonesia, so I we expect that you can elaborate the context of disaster management from your side, from your country. Probably you can also tell that in the context of Aceh or the place where you are. And also from those who come from Japan, we expect you can elaborate the country context that related to disaster management in your country. Third, we expect all of us will do a review process in the country disaster management based on the recent global framework on disaster risk reduction. It's called Sendai Framework for Disaster Risk Reduction, or in short, we call it SFDRR. This framework is expected to be implemented between 2015 and 2030. Right? Right? Now, on the session one on disaster risk and global frameworks, um, s- we all of us, I assume that we understand that there are two important events related to tsunamis in this century. The first one is the 2004 Indian Ocean tsunami, or in short, we call it IOT. And then the second one is the 2011 Great East Japan Earthquake and Tsunami, or in short, we call it GEJET. The first one, it's occurred exactly here in Aceh, back about 18 years ago, and it caused a lot of trouble here, and we have been recovered almost 2 decades. So the next 2024, we will commemorate the 2 decades of the 2004 Indian Ocean tsunami. It caused a lot of trouble, of course, and also human casualties. And the second one, it also caused a tremendous number of human casualties. Also, the amount of economic loss that caused by this event never been ever occurred before. So that's why these two events are very important to talk about, and why they then motivate the change, the way we think about disaster management, or the way we practice or we engage with the community when we do disaster preparedness. So um, the change that we are talking about are not only in the way that we understand the disaster itself, but also in terms of how then we anticipate, for example, right? Before the 2004, if you could remember, a lot of responsive or rather than reactive actions being delivered by stakeholders or even the community. Uh, there's a bit view number of theories or application where people think about preparing to anticipate disaster before it happened. That changed a lot after the 2004 Indian Ocean tsunami, after the IOT. Then we adopt a more comprehensive and a more solid concept of disaster management, where we think about a disaster, post-disaster, and pre-disaster cycles. So I'm not going to lie that uh, there are also conventional ways still going on in the field, where probably some of people or some of the area think still adopt the old versions of disaster management, where they think about reactive actions rather than proactive actions. So recently, the development of science and technology have changed a lot of things, including the way we anticipate the disasters. So now a lot of effort, a lot of researches have been conducted to strengthen the effort on reducing the risk of a disaster before it happens. So that's a positive things that we already witnessed almost 18, more than 18 years after the IoT. and more than 10 years after the gadget. And the concept and the practice in disaster management, it's evolved, it's changed from time to time. And even though we have a global framework on disaster risk reduction, we still have to think about the context of a community. Because when we think about context, the words of context here is very related to a society, to the culture, to the economic background, or to the capacity of the community itself that then, construct a larger view, a larger pictures of a disaster management in that area. So don't think about having a copy and paste action in disaster risk reduction. What I mean in copy and paste, like if you think that this concept is very good in one country, it does not mean that it can be like 100% applicable to other part of area in the world. Although probably one country is more advanced than the others, it doesn't mean that the solution that applicable in the advanced country can be applicable to less advanced countries or developing countries. The IoT happened in Indonesia, in Aceh, which I think we all agree is still a developing country. And the gadget in 2011, it happened in Japan, which widely acknowledged as a developed country. So we already being exposed a lot of examples on how Japan mitigate impacts of certain disaster, including especially tsunamis, how they construct seawalls or having coastal forests, a very thick coastal forest, or deserted coastal plain area, removing people to safer area. That is a very good example. We can probably follow that kind of step. By following the step, it does not mean again we are exactly do the same thing what Japan do and do that in Indonesia or other part of the world because we are dealing with a different context. We are dealing with a very dynamic aspects of disaster itself, which is human. Okay, so that's why we need to think about this more comprehensive, not biased, right? Um, and also in a rather more technical or probably more detailed level, we need also to think about one-to-one capacity, one person to another person capacity. We understand that there are people with disability. These friends, these colleagues with disability, they probably cannot, adapt. They cannot understand the way the disaster that we perceive. And on the other note, for example, gender bias. Okay. Oftenly we heard that women are weaker than men. On what context? That's another question. When we too much emphasize on the weakness of the woman rather than the strengths of the woman, we are trying, to promote a bias concept of looking at one person and another person. And this is why then the discrimination late happen in the field. So in the concept of disaster management, we need also to think about a full perspective, a full spectrums of community themselves. One person may not be the same to the other person, so you cannot just copy paste the solution to whole community. So we need to think about one person to another person, although we probably need to provide a more general one, but make sure no one left behind. That's the concept. No one left behind mean that we cannot just ignore, we cannot just avoid the talk someone from minority groups or someone with disabilities and so on. So that's what we are trying to ensure in the concept of sustainable disaster risk reduction. Okay. Right. Now, let's see the some lesson learned from Banda Aceh, uh, the place where I'm here right now, where this training is conducted. Um, this is the story of the 2004 IoT, right? It happened in the morning on Sunday morning on 26 December 2004. The epicenter of the earthquake is very close to Simeulue Island uh, of Sumatra. I'm not sure if we have any pointer. No, sorry. Sorry. No, not pointer. No, sorry. Yeah, sorry. I think I'm going to show you this. No, is it there? How do I? Listen. You know? Okay. Okay. Good. All right. So this is the epicenter of the earthquake, right? Over here. The magnitude of the earthquake was told 9.2. Some told even 9.3 moment magnitude. So um, there's a small island over here. Sorry. Yeah. The Here we go. The Simeulue Island. Okay. This Simeulue Island is very popular for local knowledge of smog. I guess uh, my friends from other models will talk a lot about this later on. But the earthquake that trigger over here then create a big rupture area about 1,200 kilometer to the north, almost close to Andaman. Close to the Myanmar, to the north of Nicobar Island. Okay, that's why a lot of water column, water column above the seafloor that change being disturbed, and then that's create tsunami. Although it has been 18 years after the event, still there are others unknown stories about the tsunami itself. I just note there are three things in my side that I still don't know. Um, the first one is, does amplifications of the wave actually play important role on the variation of tsunami wave height along the western coast of Sumatra? Wh- What I mean with amplification is that, sorry. Okay, all right. The wave height over here is much larger than the tsunami wave to the south of the area. So, what is the cause that kind of phenomena? Probably um, one of the answers, probable answers to this, probably because of the amplification factors, because the shape of the coastline is different from one side to another. Another one is the slope. We can simulate numerically by using computer, but exact answer to that, we need a lot of research to, you know, to fully answer the phenomena of the amplification, whether it is excess or not. The second one, what happened with the Nicobar Island during the event? The Nicobar Island is over here, to the north of Aceh over here, actually is exactly at the center of the rupture area. But very limited story or very limited research has been done in that small island. Probably one of the reason is that small island is belong to India, and um, it's difficult to access because there's still like indigenous people still there, I probably some of you heard that a couple years ago there one of incident where a researcher being killed over there because the indigenous people thought the researchers tried to steal something from the island. So it's kind of safety issue too that hinder research to do in that area. So exact process, exact incident or exact phenomena that happen in Nicobar Island still are still limited in the publication. And the third one that I think still a big question to us is that be- just 3 months after the 2004 IoT, there was also a major earthquake in the north part of Nias Island. So Nias is over here. Hold on. Sini. All right. Nias is a bit to the south of, sorry, I'm going down over here. So the epicenter is over here. The magnitude is 8.5, quite big, and also close tsunami. The question is, do these two events are connected to each other? Do the 2004 IoT and the 2005 NIAS uh, influence to each other? Whether the 2004 trigger the 2004 NIAS? What kind of scientific evidence we have to that? So that's still a lot of things. So don't think that if that happened already happened like to the case, we know everything about the 2004 event. So exactly the same with the 2011 gadget. If you notice with recent publication on the gadget are still coming out. So means that researchers and scientists are still looking at evidence, looking at a phenomena, what can be, what can be explored, what can be told based on the 2011 uh, gadget in Japan. So um, yeah, I encourage because the participants are young professionals in DRR. I encourage you also to not give up the event, although it already 2 decades. You still a lot of things you can do uh, to know and also to investigate or to do research on that. So let's. Oh no, I go back. So let's see. This is Banda Aceh, is rather very flat. Okay. Um, if you are have never been to Banda Aceh, I just want to show you how flat it is. Banda Aceh. This is the whole Banda Aceh. You can see if you sitting at the right at the window side on the right side of an airplane, you can immediately see this kind of view when you land in Banda Aceh Airport. And along the coastline, it's only have a sea dike like this one over here. That's the only protection that we have. Although almost 2 decades, we just only have this one. So if you compare to the situation in Japan, if you went to, if you go to somewhere like um, uh, I'm not sure with the Sendai plain probably and around the Sendai plain, you probably notice that they have a giant seawall over there already. Even they have a coastal forest, very thick coastal forest, and also elevated road plus a canal. So they have a multi-layer defense system for mitigating impact of tsunami. But I'm not sure if all of us agree to construct a giant seawall to surround Banda Aceh city for that purpose. I guess most of us not, right? So again, if you don't agree having a giant seawall surrounding your city, on the other hand, Japan have already has it. That's the context that I'm talking about actually. We cannot just simply, taking the giant seawall in Japan and construct over here. a lot of things happen because we have a number of fishermen communities in that area. If we construct a giant seawall, that means we block the access of the fishermen to go to the sea, right? Furthermore, a lot of people like to go to the sea, to the beach, to see sunset or just for recreation. I don't think there are people like to see a wall, when they go to the sea, you just see a wall, a giant sea wall, nothing else. It's like being in a prison. So that's the thing, shape the mitigation that we choose suitable to our city. Yes, in terms of economic perspective, we probably don't have that much money to construct the structure. But although we can afford to have that one, I don't think people will agree. Uh, Other stories that in the Sendai Plain, if you have a chance to go there, people being relocated to somewhere farther away from the coastal area. But you see here in this picture, still there are many houses just next to a canal over here. That houses were built almost exactly the same where they were before the 2004 tsunami. It is not easy to relocate people farther away from they were without a certain process. But I don't say that relocation is bad, but it will involve a lot of process. It's not just one way process. All right. What happened with the number of people over there? Let's see the left hand side figure over here. This one is a map of Banda Aceh where we can see where the area is totally destroyed, marked with the red over here. And then severely damaged is marked with the area with pink. And non-affected area was rather gray color over here. So for the totally destroyed area, there are two sub-districts named Meraksa and Kutaraja. So you see on the right-hand side of the slide, there are three figures. Okay, the top one was for the two sub-districts that were severely damaged by tsunami. So the number of population after the tsunami decreased sharply, right? Sharply to 2005 record of his, that is the lowest one. Most of the community of in these two districts were killed due to the tsunami, but some of them uh, seek shelters to other places. Not necessarily they died because of tsunami, but most of the community died because of tsunami. But you see, recently the number of uh, population growing significantly. If we compare with the 2015 data, that almost like half of the data that we have in 2004 or before the tsunami. So now it's 2023. I guess probably the graph is almost the same with the before the 2004. Now, so was the 2004 is the only tsunami that occurred in Banda Aceh? That's another question. This is the change of coastline of Banda Aceh. This is before tsunami, and this is just exactly 3 months after tsunami. You can see that how the coastline changed sharply, and let me get back to yeah. Actually, the build-up area over here represent houses and buildings and so on. But 3 months after tsunami, you can see that color disappeared, right? And even the shoreline being eroded severely and opening coastal lagoon like this one without any barrier from the open sea. But then this is the condition in 2015, which is almost the same like what we have right now in 2023. People are getting back to the same place where they were before the tsunami. Although we have artificial coastline over here with the sea dike right here, but we don't see any more like fish ponds or any ponds a lot in that area because um, the environment changed. Okay, okay, I need to speed up. Now the IoT itself affect around 21 countries in the world, in especially in the countries that located in the Indian Ocean. And the farthest point that affected by the tsunami was eastern part of eastern coast of Africa continent. In total, about 230,000 people killed, but exact number on the human casualties probably will never be known. Okay, because the record and other things will never be known exact number of human casualties due to the impacts of tsunami. In Banda Aceh alone, in Aceh alone, we lost about 130,000. 130,000 where mostly people were killed in Banda Aceh. Because in Banda Aceh, we lost around 70,000 people. So more than half of the 130,000 people come from Banda Aceh and some of them from Aceh Besar. So, um, so the statistic of human casualties that published by Friedman in 2014, you can see that on the graph on the right side of the slide. Here, this dashed line represent number of casualty from females. Okay, but then this is for male, and the X is for the age. You see that a younger one, 0 to 4, probably not different between male and female, but when it's getting older or high class of age of the population, we see that big difference between female and male for the victims of tsunami. Big number of human casualties were recorded from females. But this research also published, also stated that um, women, children, and older people were more likely to die than the prime age men. Mean that the prime age is like maybe 35 to up to 44, that the prime age. I'm not longer prime age, by the way. Okay. So in that class of the victims, women, children are more likely to be victims. And household composition play a key role in survival in the context of IoT. What does it mean? It means that if a house they have a very clear leader in the house, they have a key survival in that house. If not necessarily a father, it can be a mother, but should be have a leader, clear leader in that family. And then woman age, sorry, let me get back a bit. Woman age 15 to 44 and children were more likely to survive if one or more men aged 15 to 44 were living in that house. So if you are between this age, 15 to 44, but and then someone, a man with almost similar group of age, live in that house, they have a higher rate of to be survive. So that's a kind of publication from Friedman, 2014. You can argue, you can also, rebut, give a rebuttal to this research if you can. But that's what they record from the 2004. Now, about the tsunamis in Aceh, whether the 2004 was the only tsunamis in Aceh. An interesting study is conducted by my colleagues at TDMRC together with colleagues from NTU EOS in Singapore. They discovered a coastal cave very close to Banda Aceh, about 45 kilometers to the west of Banda Aceh. So this is this coastal cave that I'm talking about. So this is the map of Banda Aceh, and the coastal cave is located over here. Okay, right. So this is the map of the coastal cave. So that the coastal cave, the mouth, the gate of coastal cave, it's located about 300 meter from the coastline. So this is the coastline over here, right? So not very fancy one. And this is the cross topographic to the cave. So this is the sea area, and this is the berm, actually the sand, and then this is the cave entrance over here, and a little bit down over here. Now, what happened to this cave? The cave preserved a very long historical record of tsunamis that ever happened in Aceh, especially northern part of Sumatra. This cave is used as a place for bats to live in. So they're actually hanging on the roof of the cave over here. So they dump the guano down to the floor of the cave. So this cave cannot be reached by normal wave that generated by wind, but only extreme wave like tsunamis. So what happened if tsunami come? The water of the tsunami is very murky and dark. It actually contain a lot of sediment over there. So one tsunami occurred, and then the the tsunami wave will carry a thick of sediment and deposited at the floor of the cave, right? And then the guano leave at the roof of the cave. They dump guano again, and then another tsunami come again, bringing sediment. It will layer again on the top of the guano with the sediment of tsunami, and that happened for several times. So based on the study, they discovered that. Oh, sorry, not this one. Yeah, they discovered at least 11 events of tsunami occurred in the northern part of Sumatra. So this is what they got from digging the sand inside the cave, right? So A, B, C, D until K are sediments from the previous tsunami, and the 2004 is the sediment that carried by the 2004 tsunami. So in total, there are 12 events of the tsunami, so 11 tsunamis before the 2004. Before the 2004, there were very limited number of people know this area is prone to tsunamis. They thought that the word of tsunami is only relevant to the area in Japan because the word of tsunami come from Japanese word. But that's not true. This area been attacked by tsunami more than 11 times until 7,500 years ago. Since 2000, 7,500 years ago. So what I'm trying to say is this area is prone to tsunami and will again hit by another tsunami in the future. So, but we not know when and what magnitude will be. So what can we do is continue to do disaster risk reduction. That's why the idea of having sustainable disaster risk reduction is important because the cycle of the disaster is not that exact. We cannot predict exactly the magnitude or the time of occurrence of a disaster. What we can do is be prepared. That the keywords for that. That's the idea why we need to have sustainable disaster risk reduction. Now, the lesson learned from Aceh also, we also encountered another major earthquake after 2004. There was twin major earthquake occurred on April 11, 2012. On that day, two big magnitudes of earthquake, 8.5 and 8.1 moment magnitude, occurred only between 1 hour intervals. And that created a big panic in almost all the town along the western coast of Aceh, and also some cities in other provinces like in Sibolga or in Padang. They also ran away. They were panicked and were ordered to evacuate from coastal area. But let's see the figure over here. So some of them run to that area and some to this area. But you see, some people also go to different direction to the other way. These people is going to that area, to that direction. Because of what? They don't have agreement where to go. Well, let's assume if you have a family, you are a parents, and you have a children in school, and then suddenly a big earthquake occur, like let's say 8.6. So everyone running away from the coastal area, but your children's school is located far from you and probably close to the coast. What will you do? Instinctively, you will go to pick up your children because you don't have an agreement with your children. If an earthquake occurred, what they need to do or what they teachers need to do. Supposedly, if you have agreement with the teachers and the student and your kids, so in case of big earthquake, I will not pick you up at the school. So you rely on yourself and your teachers to evacuate, for example. That's this kind of picture will never happen. So that's the story why we need to be prepared. We need to have an agreement long before that disaster occurred and do some drills, right? Now, let's get to some theories on that. Why we this kind of this training is important. Why the sustainable disaster risk reduction is important. I have elaborated in the previous slide. Now, some terms that I would like to highlight is on risk, hazard, vulnerability, and capacities. So when we talk about risk, we actually talk about a probability of an event. So not exactly that already occurred. So we are talking about something that's going to happen in the future. But the risk itself is combination between hazard, exposures, and also vulnerability. Okay. Then the hazard itself is what the cause of that disasters. It can be natural, also can be non-natural. Okay? And then the vulnerability is a condition that determined by physical and social, also economical and environmental factors that contribute to the losses after disasters. And capacities is defined of combination of all strengths, right? All strength that probably can be used, all resources that can be used to recover or to reconstruct after certain disaster. Now, this is a formula actually for risk. I think most of you probably are very familiar with this conventional formula, but it's very good to to understand the concept of disaster risk reduction itself. The risk is equal to hazard multiplied vulnerability divided by capacity. So if you are talking about reducing risk, you just need to play with this kind of formula. Either we eliminate hazard or we reduce vulnerability or increase capacity. That's it for disaster risk reduction. Of course, nowadays the concept of risk not is not limited to this kind of formula only, because some scientists already developed other more advanced theory on risk, calculating risk. One of them is on probabilistic, using probabilistic theories on risk. Maybe some of you come from mathematicians, so probably you can use a stochastic model to estimate the risk and so on. So that I guess more complicated mathematical formula than this one. So, but in general, the the idea of risk same is the same. And if you are talking about reducing risk, we just need to think about this formula. Okay. Okay, right. Um, the classical ways of risk itself is actually it perceived as a non-transient process, means that it doesn't change from time to time. Okay, and simple to understand. That's an advantage of having classical ways, and better understand and easy to be used as a communication tools to community when we do a campaigns on disaster risk reduction, rather than rather than we show a probabilistic or stochastic formula. I don't think it make sense to to use that a kind of tools to do the campaigns. But if you use that simple formula, it's easy to communicate and also to get a better understanding from the community. Later in the module, you will also learn how to communicate risk or risk communication, right? So you will need to think about simplifying a complicated one. So one of the thing is on showing the risk formula. Okay. All right. Now, disaster management, you are probably familiar with this one. So what happened after the 2004, we adopt this two pace or two side of disaster management before and after. So before we have preparedness and mitigation, and after we have response and recovery or reconstruction. Right. Now, about global framework, we have three important global framework on disaster management. Recently, we adopt Sendai framework for disaster risk reduction. It is an active framework for disaster risk reduction that is aimed to be applied until to 2030. So we still have how many years? Like 7 years uh, more to complete the whole uh, task or the whole activities related to Sendai framework for disaster risk reduction. This framework has four priorities. Priority one, understanding disaster risk. And number two, strengthening disaster risk governance to manage disaster risk. Priority three, investing in disaster risk reduction for resilience. And priority four, enhancing disaster preparedness for effective response and to build back better in recovery, rehabilitation, and reconstruction. Especially for, I would like to focus on build back better. One disaster occurred, you will need to do emergency period, emergency phase, and reconstruction phase. After the reconstruction, we aim actually to have a condition better than before the disaster. That's what it means with build back better. But recently, some scholars even add another terms with build back better and safer. So it's up to you to choose which one. But um, well, according to SFDRI, just build back better. But if you are want to choose build back better and safer, it's free to do so. But it's very similar, and I guess not that different. You just want to emphasize that we will have a safer condition after the reconstruction process. DRR itself should be aligned and should be following the SDGs, IRIDES, or Sustainable Development Goals. Um, in Sustainable Development Goals, it has at least two goals that are very close to the idea of having disaster risk reduction. Um, Number one is the goal number 9, which is to build resilient infrastructure, promote inclusive and sustainable industrialization and foster innovation. Okay. And then goal number 11 is to make cities and human settlement inclusive, safe, resilient, and sustainable. So these are two SDGs that are very closely related to disaster risk reduction. Disaster risk itself has a three component, as I said before, following the previous formula. We have hazard like tsunami, earthquake, landslide, and so on. It can be also non-natural, for example, um, disease, for example, coronavirus. And we have population like vulnerability, like population, poverty level, land use, infrastructures, and highly risk group like elderly, early age group, and then people with disabilities. So we group that in as a vulnerability. Then capacity, for example, we can have a number of trained and skilled personnel as a first responders. So if the number of are increased, that means we increase also the capacity. So it means that we reduce risk. Okay. And also importantly, I would like to highlight the capacity on science and technology development. Okay. So having technology that can help us to reconstruct or to mitigate impact of a disaster, that also part of capacity. So even an area does not have any research or any technology applied to mitigate impact of a disaster, that's probably the capacity is low, right? Okay. Last part, I would like to speed up my slide over here. We will have tsunami evacuation and early warning system. So we will have a process to be designed and facilitate smooth and on time process to save community from potential tsunami affected areas. So that's the aim of having tsunami early warning system. All right. I think I would like to stop here because my time is up. But before we end, if you have any questions, one or two, before we go to the second session, uh, please raise your hand or unmute your mic. Anyone from the room and also from the Zoom?
Hello, sir.
Someone is raised hand.
Can I ask a question?
Hold on. Can't see this the Zoom. Okay. Is I think I'm the first one is Harfe Pierre Siddhartha. Am I right?
Yes, sir. The
Okay.
pronunciation is right.
Okay. Go ahead.
Okay. Beforehand, I would like to thank you, sir, for the very comprehensive presentation. And let me introduce myself. My name is Pierre, and I'm from the Institute of Technology Bandung. And I would like to ask a question, actually. So previously, you explained that several, let's say, mitigation methods are not applicable for Banda Aceh for many reasons. But I'm actually curious on what is actually the methods that has been implemented and maybe for now has already been on the plan to be implemented in Banda Aceh in terms for the disaster risk reduction. Thank you, sir.
Thank you. So that's an interesting question. So if we don't have any seawalls, if we don't have any, well, let's say thick coastal forest, so what do we have in Banda Aceh, right? So okay, if you have a chance to visit Banda Aceh, you will see a number of escape buildings. Okay, we have now we have 6 tsunami escape buildings. Um, that can facilitate each of them can facilitate about 800 people to evacuate it, at the same time. We have evacuation routes, so will see some signboards along the road especially around the coastal area, where that point out where you need to run or to evacuate yourself once evacuation order is released. That can be also categorized as a mitigation, structural mitigation. Um, and if you remember, we have a coastal lagoon in front of Banda Aceh. So that coastal lagoon is also can reduce the velocity and also the height of tsunami waves. So one thing that we need to make sure that we need to preserve that coastal lagoon over there, not to be reclaimed or changed to something else, because the lagoon itself can dampen the energy of tsunami waves.
Thank you very much, Prof. Syamsidik's very interesting talks for the session one. I believe that everyone are still, still on for today. So I would like to say hello to Prof. Anawat. I think Prof. Anawat is already in the Zoom.
Yes, hello. Let me just change my background.
Yeah. Okay, so how are you, Prof. Anawat?
Yes, I'm doing good.
You're
We have
really good. I believe that there are snowy there. It's
no, we have a warm
winter, right?
no, we have a warm
Oh,
year.
really? Oh, it's a warm one.
There's
Okay.
no
Okay,
snow.
that's pretty nice. Yeah. Okay, so we will because of the time I don't believe that we have the break, so it's already like 11 past 25, so we run out like 10 minutes of your schedule. So we have Prof. Anawat today with us from IRIDeS, Tohoku University in Japan. I do believe that most of the participants already known a lot of Professor Anawat publications, and I believe that some of them are citing your works, including Syamsidik as well. So, Prof. Anawat today in session two will discuss about the preparedness and mitigation. So, without further ado, I would like to welcome Prof. Anawat to present.
Okay, thank you very much for your introduction. So yeah, let me just start. What time shall I finish? One. So we keep
You
the
have,
schedule.
you have about an hour.
Okay, so yeah, I
An
heard
hour,
from.
yeah.
Okay,
About
so
60 minutes.
yes, okay. So yeah, I can, because I think you are behind the schedule, I can make a little bit faster. And I understand that you already some part of my talks has been already discussed through Professor Syamsidik lecture. Can you see just a moment? Can you see my PowerPoint?
Yeah, now we can see the full screen. Got it.
Okay, great. Well, thank you. So let me just start. So, well, actually, this is also what you have been already discussed. Just again, we mentioned about SFDR, and this is what we have done so far since 2015. And yeah, so you mentioned about the Hyoko framework, which actually today is the day of Kobe earthquake in 1995. So it just by chance that this is just the same day, 17th of January. And yeah, so this is how we develop the international framework for disaster risk reduction. Is it just the same thing that I would like to talk or introduce at the beginning of my talk. And just to extend what Professor Syamsidik has mentioned in his lecture. To do that, of course, he mentioned roughly about like there are some indicators to evaluate this SFDR, and for that, for example, Tohoku University and UNDP and Sendai City and other organization, we establish a new global center for disaster statistics. This is in order to evaluate if SFDR is made progress, or how we quantify our disaster risk reduction performance. For example, these normal indicator like number of deaths or number of affected people, or loss or damage critical infrastructures after disaster. Of course, it's quite common in Japan to have such data collected after disaster, but it may not so well organized in many countries. Indonesia is one of the pilot country of this project, this center, and they are in contact with your central government and probably the local office of central government like BNPB or other organization to collect such kind of data. Well, and I think this is what you have been actually discussed in Professor Syamsidik's lecture, so I think I would like to skip this part. So again, I would like to start from showing you some background of tsunami in the world. As you can see that on the right figure, this one show the simulation of tsunami height from 1970. So like our direct experience. I'm not sure who are attending in the Indonesian on site, but I'm sure that most of us we was born more or less around this year. So we mostly directly experienced or heard the news of 2004 Indian Ocean tsunami, and also like 2011 Japan tsunami. So this is our direct experience of large tsunami. But if you look at the figure on the left, we simulate other big tsunamis back to 400 years ago. So you can see that actually it's not only in Indian Ocean or in Japan, but areas like from Alaska to the west coast of the US, the South America, and also even in Atlantic. There's also the high hazard of tsunami, but it's not quite well known compared to the mostly recently happened in Indian Ocean and in Japan. So yeah, knowing this background, so we can see how the awareness of people in each coastal area in the world have different awareness level. And when we talk about the future, this is another issue that we would like to we have to think from now, and it is like a global issue that we start thinking about the sea level rise caused by the global warming. So of course, if we talk about tsunami, we have to consider the sea level, which is the initial condition for tsunami coming. For example, in case of 2011, we were kind of lucky that it happens during the low tide. It's not if it was happening in the high tide. More than 1 meter should be added in the tsunami. But what I'm talking right now, sea level rise, is not about the tide, but the average sea level. As you might know, that this is caused by the warming, global warming. So we also have done some numerical experiment, and for example, in some area, like in this area, we show that how large tsunami could go more far inland, or how, for example, if even the sea level rise for 70 centimeters, but in some place the rise of the height could be double of the height of the sea level rise, something like that. And this is just to show how far the distance the tsunami could penetrate even further inland. And yeah, so recently, even in Japan also, there are news, they have high awareness of this kind of issue. So for example, this school children was survived in this space, just almost they could survive. But if the sea level rise in the future plus 1 more meter, so this room will be also flood. So that may be not safe in if the same tsunami and plus sea level rise issue, something like that. So these are things that we have to think. And also on the other side, if we talk about the frequency or how frequent tsunami could happen. For example, this one paper from our colleagues, they show the plot between the expected tsunami flow depths and the return period. So without the sea level rise, it's about 900 years. But if we consider the sea level rise, the return period will be reduced from 900, well, almost 1,000 years to 800 and 400 years, respectively. So that means at the same tsunami, but because of zero rise, we can also interpret that the frequency or return period will become short, or that such certain height of tsunami could become more frequent. And so to do this, we need kind of numerical simulation weight. This is a way to simulate the things, the tsunami. And this is just for your information. So we have a model to, for example, to simulate how large the sea floor rise up and goes down like this, and we simulate the sea surface like this. That's why we can see that like the area like in Banda Aceh, you or Sendai, we see the some area we could see the drawdown first before the coming tsunami, something like that. And maybe I can just skip this just to show that we have some numerical technique to simulate the shape of sea floor, this shape like this one. And also, yeah, so our university, we have developed such kind of numerical simulation tools. And we, of course, for international scale, we use the global published topography or bathymetry data this size. And for local simulation, for example, in Japan, we have Geospatial Agency, or in Indonesia, you have BIG. Which are organization in charge of such kind of bathymetry data. And I guess probably in Professor Syamsidik lecture, I guess that he's already mentioned about other cause of tsunami. So again, we have also done some study related to non-earthquake tsunami as well, like what happened in Sulawesi, in Palu. In 2018, where submarine landslide like this was generated by the earthquake, and also, like you can see the orange part, and also so because of the nature of several submarine landslides, so you can see that there are many sources of landslide happen at the same time, and the arrival time is pretty fast because the landslide like this is occur very near to the shore. And also another example that is quite hard to work with, which is you may remember 2018, the crocodile eruption. which this time no earthquake at all, but the eruption caused the collapse of the mountain itself, and it generates tsunami and many damage and also casualty. So this kind of course, right now, your government have already deployed some sensors around this area, but still, it's quite difficult to predefine where such phenomena might happen, or where we should deploy the sensors. I have one student right now from Indonesia. He's trying to propose the kind of array of observation against future tsunami in Indonesia. And also more quite new example, which is the one, if you remember, the eruption of large volcano in Tonga as well, in January. I think exactly about the same day. Yeah, it was on 15 January. At that time, also large eruption, and also we learned a new thing that the abruptly change of the air pressure caused by the eruption also generate tsunami, which could travel as far as from Tonga to Sendai as well, and not to Sendai only, sorry, to Japan as well. And this is just how it looks. So the top one is the change of the pressure, and this one, the second one is the tsunami, and it's arrived Japan. And there are several ports, well, fishing port, that the fishing nets or fishing boat was got damaged by the tsunami as well. So again, so of course, for such non-seismic tsunami, it's quite difficult to predict, but for earthquake source, we can do something like this, to like sand deposit survey. This one example from somewhere in Malabo, where you can see different layer, which is from the sands from tsunami in the past, and also then the soil, and then sand, tsunami sand, and then the soil. So we can do the dating to estimate how the frequency of this. And also in Japan, also we have such similar study, of which we understand more. And also we also, from the simulation, we can understand that, okay, at the end, where the last location where we found the sand, what is the tsunami properties? Like, what is the minimum flow depth that required to make the sand deposit, or flow velocity? Of course, we know about the sand deposit of 1,000 years ago, which this kind of research started 20 years ago, but we still have no such information of like what's the flow depths or flow velocity or more location. We only know in Sendai, so that's led to our underestimation of this tsunami. And of course, in Japan, we also have large documents which record things related to disaster. For example, this tsunami in 1611 is not only, well, the tsunami deposit, the science behind the sand, and not only the engineering perspective for the simulation, but also well, we are working with professor in history who can read like difficult Japanese written record or documents, and we know like from the records that how large tsunami or where or when tsunami hit the area. So we can also use that kind of information to trace back and to use as our simulation condition. So let's talk about a bit more in Japan, how we protect our community based on historical tsunami. So yeah, so if we focus on Tohoku region, since 100 years, more than 100 years ago, we have many earthquake, and since this period, we know that okay, large earthquake, maybe we might have tsunami, but some case is not like that. So we learn case by case, and we start to build some seawall or floodgate or something like that. Some structures after 1933, and then it was successful for those village who has structures, so that the tsunami from Chile in 1960 had less damage to that villages. But still, since then, that's a bad point, that we overconfidence of having such structures. And after that, we learn from these two tsunami that tsunami could arrive very fast, and it sometimes could also bigger than we expected, and similar things happened in 2011. So we start, as Professor Syamsidik mentioned, that we start thinking about disaster risk reduction. Before that, we have an idea like we can fully protect, but so we change the word, even Japanese, from prevention to reduction. This is how we change in our mind. Because of the time, maybe I can go a little bit fast. So this one is just to show that this is the plot between the height and the death ratio of each historical tsunami, and you can see that in the old time, tsunami was high and the death ratio also high, but based on the experience of previous tsunami, you can see that in some case even the tsunami was high, but the rate ratio is small. So things like that, which also can be similar to other events from non-Japanese tsunami as well. In Japan, what we are doing, how we warn people. So since 50, 60 years ago, we have such warning system, and it was about 20 minutes at the beginning. So what we use database. So we assume many earthquake parameters, and then we recalculate based on our assumption of these earthquake parameters, and we simulate and store in the database. And once earthquake happened, we took it from the database, the closest information. So yeah, from the improvement of computer or computational techniques, or we could reduce from 20 minutes to like 5 or 10 minutes. But still, as I mentioned earlier, these two tsunamis show that tsunami could arrive very fast. So until now, it used to be within 3 minutes to announce the first warning message. And if we talk about Sendai, again, we have experienced many tsunami in the past, but still, as you can see, there are two types. For example, as you can see, in 1896 or 1933, we had a very large tsunami in the northern part, where it was like 20 or 30 meters. But at the same time, in the same area, but we have another cycle of small tsunami and small earthquake that could happen every 40 years. So we also start learning from this event, 2011, or other tsunami in this area, that it could be more than one earthquake or tsunami cycle exists in the area. So what happened in 2011? As I mentioned, we didn't expect that such large magnitude in Japan. So, and also we didn't store or calculate such a large earthquake in the database, and it take more time to for the seismic wave observation, more than 3 minutes, which is actually like this is they will disseminate the warning within 3 minutes, but actually the ground shaking of the 2011 earthquake itself, it was like more than 3 minutes. So still we are under observation, but we have to release the warning message. So that was very difficult things to do to deal with the real-time warning at that time. That's why at the beginning the warning was also underestimate, and then once we, and also the electricity was down. So even the government upgrade the warning, was some local area they couldn't receive such things. Right now we are we move setback the living area to safe place, or we be more prepared about the electricity generation during the emergency, or we like this this is the waveform, the elevation that we observe inland near the deep sea, like 7 meter 6 meter tsunami in the deep sea. So that should be very high when it approach inland. So for this one we also have install many sensors, undersea seabed sensors cable, to improve observation and of course the warning in a real time. So, and also for this one, it's not only for the technical issue, but also for the psychological, or how we convey the scientific information to the public is quite important. Because, for example, at the time of 2011, we used to have about 8 levels. So we announce in numbers, like this number, we expect how large tsunami is coming. But we've learned that for such large tsunami like 2011, it's quite difficult to punctually or very high accuracy in giving numbers for warning. So from now, and also, I mean, if we set numbers, people will compare. For example, they know how the height elevation of their living place, or they know that, okay, we are living behind 6 meter seawall, for example. So if the government announce the number, somehow people will compare with this elevation or seawall height, and then that might prevent people from doing some evacuation. So for such a large tsunami, so government might intend not to give number, but just to say just only word like major tsunami or something like that, just to as a tricky way to well, psychological way to encourage people to do evacuation. This is what I have just mentioned, that so right now there are many projects to increase the observation of or observation and warning. So for this one, like this, we have already deployed the sea bottom cable sensors like this in the East Coast, and also already exists in the West Coast of Japan, even before 2011. This one after, on the right is after 11. But still, there are some exceptional case where the assumed fault, the earthquake fault angle is not the same as what we expected. And well, actually, this tsunami happened when I was attending IRIDeS in Banda Aceh in 2016. So I didn't experience this ground shaking, but I mean, it make us surprised, like how JMA or the government agency in charge underestimate again the tsunami. It was issued as as advisory. Sorry, I forgot to translate. This one advisory, but suddenly after 2 hours they upgrade to tsunami warning, just because of you can see from the snapshot that from the local reflection and amplification, so the wave is getting bigger than we calculate in a database. So we have to the government also already increase some other possibility of the fault parameter, earthquake parameters in this area to improve the accuracy of the database. So my second part will be about tsunami countermeasure in Japan. So I could hear from after Professor Syamsidik lecture that we discuss about the like, for example, in Aceh or in Indonesia, where we have no such structures, but in Japan we have quite frequent tsunami, and we spend also kind of we invest on the structures as well. So just for information, so we have several structures in Japan. As you can see, we have the breakwaters, which is the structures in the sea, where we expected that it can help to reduce the amount of water coming into the bay, and also, of course, if the height is enough, so that we can protect also tsunami inundation. Seawall is along the coast. This is already, and the flood gate as well. As you can see from this figure, as tsunami can also easily go through river, and it can reach to the city or town behind. So in some area, in Japan, we also built a floodgate, especially to prevent from tsunami, and it was successful in this area as well. Of course, there was large objection at that time, but the village leader, he decided to build it, and it works in case of 2011. And so highland resident is another thing that we might need some construction just to build or to cut mountain or just something like that, but it's probably one of the good way to do this. If there's no problem related to if they are not fishermen, for example, that should be fine, or the water access to water or some other cultural issues. And so and also in Japan, we also have such kind of trees, not mangrove, but we have pine forest. But this picture was before 2011, and this forest was totally gone. So again, last summer I have a chance to brought some colleagues from Indonesia, and we have been discussed about what we call gray infrastructure, which is like seawall or other structures, and the green, which is like the trees infrastructure, green infrastructure. So again, we know that such kind of trees, pine trees or mangrove growth, of course it has disaster mitigation performance, but it at certain level, I would say like 3 or 4 or even 5 meters. But if our expected tsunami height was like 10 or more than that, it's beyond the capacity of the green infrastructure. So we need, like in Japan, we need a certain levels. So for example, in I think I have in let me just go to this slide, and I will come back later. So for example, in Sendai, the area is so flat, so we need a certain levels. We need a seawall, we need trees, and before 2011 we have no this road. We have the road, but it's on the ground, and we have the highway. So even tsunami overtop the seawall that destroyed the pine forest. Yeah, but it was luckily by chance stopped or blocked by this highway. So we got this idea, so we increased the land elevation of this road to 6 meter, so that it can be another layer to reduce the tsunami energy. But for the northern part of Japan, where they have a mountain already, so the solution is pretty well, it's easy to say, but I mean, they just they could clean this area, or maybe do cut some trees, and they ask people to move to this area, or public area like this, or increase the land elevation here. And yeah, this is just the same thing. And well, actually, I'm not sure if Professor Syamsidik has mentioned, also we have similar idea in Madache, the ring road as well. So that is kind of the idea how we can making use of the tsunami facility, not only for emergency period, but also as a daily use as well. And of course, to decide the height of this road, we also did some simulation. What should be the best height or best combination of these infrastructures? So let me go back. So again, so for this one, and this is I already explained. So yeah, so as 2011, we know that some area like what we estimate as the blue area, but the actual tsunami was in red. So in some area it was largely underestimate, but in some area was about the same. So it depends on the location, but that is the importance of how we need not only these structures, but we need warning and also land use management as well. So these slides, these two slides, just would like to share you some fact that from the survey questionnaire, like why there are so many casualty in 2011, because like still at that time more than almost 60% of people use car and they got in a traffic. And yeah, so this is just a fact that just for those who evacuate by walk, it's up to 500 meters, but the area with the distance like 1 kilo, 2 kilometers, people tend to prefer to use car. And even from the survey, we also found that only 2 minutes, in average of the time from earthquake generation to evacuation starting time, in average is about 2 minutes. So as soon as possible, we should encourage people to evacuate to the high location, and not to move back to once they already evacuate to the safe place. So also need to encourage them not to move back to the risk area again until the government has already announced cancellation of the warning. And sorry for back and forth, but for structure itself and also for the evacuation itself, since 2011 we have decided this new idea how we decide the height of structures and evacuation planning, which we call tsunami level 1 and level 2. Level 1 means for small tsunami that could happen like 100 years or 200 years or more or less, frequent. So we need a certain height of the structure so that we make sure that such frequent tsunami will not overtop the structure. So, and recently we also start to think about if we should increase the height, by considering also the sea level rise, but still it's not the easy topic. But this again the way that okay, for frequent tsunami we should have in Japan we should have a certain height of protection. But then for level 2, like 2011 in Japan or 2004 in Indian Ocean, it's super high. Of course, we have enough technology to build very high seawall, but it's not work in practical. So we make sure that the structure will be strong enough, and even the tsunami overtop the structure, we should still structure should be there, and we have enough evacuation plan, or we make sure that people could save their life even under this situation. And again, we also need the land use planning behind, and this figures also show like the map. The base map is the village, the area of the village reconstruct after 1611 tsunami in Sendai, and the blue is the area of 2011 tsunami. So you can see that actually the in the history, the village has been built quite far enough inland, right? But after Edo period, they start more urban development, and there are many new coastal community near the coast. So that's why this the same strategies, the same damage was happen again in 2011. So it's kind of challenge how we could keep the no-build zone along the coastal area to our next or like so many generation in the future. This is just to show you some examples of pictures, like how the difference in like these two areas, they have the offshore breakwater. So the damage, of course, it happened, but the housing still remain. But these two areas, they have no breakwaters, so the damage is totally like this, so kind of different. And also you can see the large scarring because of the high velocity of tsunami behind the seawall. One is over top like this. So yeah, we need to strengthen the structures behind the seawall. That is another issue in coastal engineering in Japan, like how we can build strong seawall to prevent such damage. And this one is just to show the performance of the pine trees. For detail, you can have a look in the slide later. But in general, we also we plot the damage of the trees against the tsunami flow depths or the size of the tree, etc. But in general, we would expect the tsunami reduction performance of the trees up to 3 to 5 meters of tsunami. And yeah, of course, and also for the building, we know that of course the reinforced concrete building is stronger than the wood, but how we can evaluate them in the quantitative way. We also have developed some functions or curve like this to understand the relationship and to be used for risk assessment in the future. And in 2011 tsunami, we also learned a new lesson that, for example, in this area, it was reclaimed land where they fill up the sea to increase the land space. And you can see that the the window size is quite small. So when the tsunami attack, before that, when the earthquake happened, the liquefaction happened and it reduced the friction force of the pile foundation. So the building lose their strength in the foundation, and also because the window is quite small, so the water could not go through the building. So the pressure largely act at the building front, and because of the buoyancy, it's helped to pull the building out and just overturn like this. So that is another issue that we have to consider when we are going to build the evacuation building. So, but sadly, they already moved many buildings. Just one building now. A police station. They keep it as a memorial to remember such kind of things. And this is a good example that we also discussed together with Indonesian colleagues last year in summer, where we in one area in Japan with a nice sandy beach in summer. So, and also the trees, but because of the tsunami, it destroyed everything. And once they would like to increase the height of the seawall, and of course it has to expand. We have to expand the width of the seawall, which will also reach the sandy beach. And then the height is getting higher, so the local people they were not happy with this plan, with objection. So the best solution was finally decide like this, so that of course we will lose the pine trees, but the main purpose of this area is recreation, the tourist sightseeing spot. So they need the white sandy beach in this area. So they keep the sandy beach area, and then they set back the area of the seawall, so that the sand beach can be like that. And also they decided to increase the land elevation behind the seawall and make the same level, so you will not feel like you have a big wall in front of you. And so that is kind of a good way, so that the scenery also good, and we can keep the height of the seawall, and we also still have the nice sand. And also they also did some simulation back until 2070s, for example, like based on the current structures or situation, or the predict wave currents in the future. We still have the sandy beach or something like that. That is kind of a good example how we consider environment and also the scenery, also in the deconstruction period, not only purely civil engineering. I think last but not least, there's also the issue of health issue. Now we are currently using the death data, like the cause of the death or where the body found. And these are the cause of death, not only water but sediments or fire or debris. So we are now analyzing the relationship between the tsunami and also the cause of the death by tsunami, so that if we could prevent. For example, we found that there are some cases that even people could survive from water, but then because of the coldness, it was happened in March, still many snow, so they was died inside the shelter where they have less. For example, they have no chance to change the wet clothes to dry clothes, or to keep their body warm in a shelter. So this kind of thing, we would like to also propose kind of guideline to take care of people in the shelter as well. And another issue is like things like structures, we can keep it as a future for as a memorial, like we also have in Indonesia. Last but not least, for well for internationally, and it was also promoted by many of UN organization, and it was from Japan. So lastly, I would like to mention about the World Tsunami Awareness Day, which start from 2016, and it is every 5th of November. So yeah, so this, well, it was happened in Japan in 1854, which this first, well, you can read this one by yourself. As you can see that the villager, the leader, he expect tsunami after earthquake, but to let his villagers evacuate, so he put fire on his dry ship, and he could let his people safe from tsunami, and he built seawall in this village, which could save his town village from another tsunami after 90 years. So it was a great story. So Japan proposed this day to UN, and then it was approved as the World Tsunami Awareness Day. So for this, we have been doing many events. For example, the museum conference, or some trainings, or like the disaster statistic center. And yeah, together with UNDP, also I also help the evacuation drills, or making the poster or guideline to the school, and it was supported by also the Japanese government. And during the COVID-19, also I also help making this kind of the guideline for COVID as well. So yeah, that's still we're still under the pandemic, but the issue of evacuation from tsunami it should be treated higher, more emergency than getting COVID in the shelter. So this kind of thing, we get the knowledge from Japan to make this kind of guideline even under the pandemic. So that is things related to the awareness day. So yeah, I would like, because of the time, I would like to stop my a lecture here, and I have another meeting in 10 minutes, 15 minutes. So yeah, I'm happy to take questions for about 10 minutes from now. Thank you.
Yeah, thank you, Prof. Anawat. I see some of the participants online
Yes,
have raised their hand.
yeah, please.
Yeah, please go ahead. I think we can suggest the Anarita.
Okay,
Anarita,
yes.
you can directly ask questions.
Thank you, Mr. Haikal, and thank you, Mr. Anawat, for your insightful presentation. My name is Anna. I'm from CHARI, a research and information technology-based social venture working to enhance knowledge management for disaster risk reduction and resilient development. So I have a question, and in your presentation, there are many examples of tsunami mitigation efforts that has been implemented, especially in Japan. And in terms of infrastructure such as seawall. So, however, is there any best practice or good implementation of ecosystem-based solution or nature-based solution in Japan or any other country to reduce the risk of tsunami that has been proven to be effective? Thank you.
Okay, thank you. Yes, we okay. So yes, sorry, I don't have that slide, but I mean, in some location in Japan where we have is it Matsushima? Well, maybe you can search later. Matsushima is kind of famous place, tourist place in Japan, in Sendai, and there is a bay and many small islands, and then we have a famous tourist area. So actually, that small island, like almost 300 islands, it helped as a natural barrier that could mitigate the height of tsunami or the current tsunami velocity. So at that time, so in Matsushima, the tsunami is getting small, and also the seawall was also low, because we know that it's a sightseeing area. So that is the kind of things that we know the danger of the location, and that's why this could help to reduce the things. And also we also found that yeah, in many places where the tsunami destroy the seawall, and then the recovery of the animals or plants is getting quite fast because no seawall. So that the animal or trees or things can be go back and forth between sea and land, right? But then after a few years, we start to rebuild the seawall again, so it blocks this kind of transportation. So yeah, it's delay the recovery. So we now we know such fact and problem of 2011. So now we are trying to quantify or stress more about this issue to improve our recovery in the future. For this time in 2011, we have less time or less consideration of the environment or this kind of environment related issue. Yeah, thank you.
Yeah, I think we still have a lot of participants that raised their hand. I think it's very interesting for your talk, Professor Anawat. We can continue with Iqbal Aziz. You want
Yeah,
to ask
please.
at the
Maybe
later?
one or two. Yes, about two more questions.
Okay.
Yeah, about two more questions. Yeah.
Okay. Thank you so much, Mr. Anawat, for the presentation. My name is Iqbal. I'm from Mudatan Bencana, a youth-led organization that supported by U.S. government regarding adolescents education. My question to you is that we already know that the Sendai framework disaster risk reduction is already adapted in so many countries, right? And the number one priority that this framework has is that understanding the disaster risk. What do you I want to ask a question for you regarding these matters. What is the key action that Japan do to give a comprehensive understanding to the adolescents regarding the DRR itself? Because I want to learn more about this. You mentioned it very briefly, and I want to explore it a little bit more. And that's the first question. The second question is that, and what do you think about digital education? Is Japan already implement this particular platform to educate the adolescents in Japan about the disaster knowledge or even like disaster risk reduction? Thank you.
You mean your first question is about like how
Japan educate the adolescents? Yeah.
Yeah, I think maybe it can be. I think your first and second question is kind of linked together, right? I mean, yeah, for the education. Well, still in Japan, we even like my son, even in under elementary school, we start teaching children even like that young. And for Japan, we have been teaching or we have such disaster related issue in the school levels. And when I think right now the level of how we educate people is quite, I think it's not big gap once as far as I see from activities in Indonesia or in Japan where we make it. But probably the thing is that the such kind of activities in Indonesia or in other countries, it just largely start from 2004, right? So that means our parents' generation still probably have less chance or experience about that. And in Japan now they are trying making use of ICT technology to help supporting the education as well, more media or something like that. So that is another thing that we can add also. But still there are some issue like what we have experienced from 2000 in 2018, the Sulawesi or the Krakatau or the Tonga, that such a new type of tsunami still could happen. So we still try to learn from non-seismic tsunami experience. that we'd like to share or to let young people know more about that. But still, in Japan, we still for example, in not only tsunami but for earthquake, we have a new way to try to teach people, or not to teach, but I mean, because in 2011 it was earthquake magnitude of 7 point something before, just 2 days before the main shock. So now we have another warning types. So if there was a magnitude 7 somewhere in the red zone, so we will announce like a new warning, like please be careful, something like that. So we try to adapt, and we try to incorporate more psychological way on how we can issue the scientific information to more local people. Thank you. Maybe one more question, one person,
Yeah,
one last person.
one more question, maybe from Cindy Hajah Fatima.
Yes, thank you for the opportunity.
Okay,
And
Cindy, go ahead. Yeah.
yeah, and thank you for the presentation. I would like to ask, as based on your presentation, you mentioned about the tsunami map in Japan, and it was simulated by some fault in around Japan. And my question is, did you use more than one faults for the simulate for the simulation? If yes, why there is just one tsunami map from this simulation? Because if I don't mistaken, in my I think about we should have more than one tsunami map from each source fault.
Oh, okay. You mean at my very first slide, right?
Yes. Yes.
Okay. So yeah, that I mean I just overlay many maps in one maps.
Oh,
So,
I see.
yeah. Yeah,
Yes.
there are many tsunami, and then we just overlay maximum of maximum many maps anymore, just to make it more easy to see. Yeah.
Yes, I got it. Thank you, sir.
Yeah.
Yeah, thank you very much, Prof. Anawat. I know the time is very limited. For those of you that have questions, please don't hesitate to email to us. We can communicate as well with Prof. Anawat, and then of course we can use the e-learning system where you can also provide any questions or discussion on those platform. Okay, once again, would like to say thanks to Prof. Anawat for his time and share his knowledge for today's session. So I think we are at the break right now. We will have a lunch break and we will meet you again on 2 o'clock at Western Indonesian time or +2 Japanese Standard Time. So bear with us and we will see you again at the time. Thank you very much. See you next couple hours. Assalamualaikum warahmatullahi wabarakatuh. One number of participants. I'm very happy to see that every one of you are here with me today, with us today. And for the session 3, we will have Prof. Syamsidik will present about the practical example of tsunami risk reduction. Then that session will be 30 minutes. Then we will have a discussion for the last in today will be 30 minutes as well. Everyone will later on will be invited to join a breakout room. The operator later on will share their screen and then you guys could choose upon the room that already provided. So without further ado, I would like to welcome Prof. Syamsidik to present his presentation on practical example of tsunami risk reduction. Prof. Syamsidik, the floor is yours.
Thank you, Dr. Haikal. Afternoon, everyone. I hope you enjoy your lunch break, either in Indonesia or somewhere in Japan, and you are content with the schedules and a further program ahead. So we have another 2 sessions actually to in this module. First, I will deliver a short presentation. Some of them probably continuation from my first modules before, and then we will then continue afterward with discussion. Um, during this discussion, we will divide the group, the class into 2 groups, and one person will be assigned as a coordinator for the group and moderate the discussion and conclude the discussion. Later on, I would like also to invite the coordinator to present their works and the findings or the result of the discussion, and then comment will be commented by others probably. And I'm not sure if other participants or even mentors will also raise some questions to what you are going to have after the session. All right. Let me start a bit with the what I have started earlier. That I'm going to continue with the session 1.3 with practical examples of tsunami risk reduction. In this presentation, you will see some option where you can, well, sort of contextualization tsunami mitigation in your area. These can be applicable, but probably not applicable depending the context, again, the context of your area. Okay. So first about tsunami evacuation and early warning system, this is a kind of continuation before from session before. So we need to facilitate smooth, fast, and on-time evacuation process during evacuation orders or during emergency period once early warning or evacuation order released from the authority. But the question is when people should evacuate and where that kind of information will be received by the community. So to facilitate and also to accommodate the information, some countries have developed the tsunami early warning system. Okay. So the objective or the goals of having tsunami early warning system is to inform as early as possible to the community if the area will be affected by a tsunami. Okay. This system is expected to provide estimated tsunami wave heights and tsunami arrival times around coastline, around projected coastline. But another thing is we need to think if one person receive the warning, what thing they need to do afterward. Certainly, if the warning contain evacuation orders, then people should evacuate as early as possible and as smooth as possible. So how this can be facilitated by structure or facilities that we have in town. Some of the examples that we can provide is by having ample tsunami evacuation signs. And then we need to have a correct routes and have some safe points in the town. These can be buildings or higher ground like hills or elevated road, for example, or elevated park and other kind of assigned location. Right. Categories of tsunami based on its arrival times. what does it mean with the arrival times? So arrival times mean the first time when the wave height reach 0.5 meter from its mean sea level. All right. The definition of mean sea level means that in the sea, there is kind of fluctuations because of tides. Okay, there's a neap tide or spring tide during the flood tide or ebb tide. So in a day, in your area, you could have one or twice ebb and one or twice flood. Um, so in average, we can then have mean sea level. Normally, the scientists will take data at least 1 month data to have that kind of mean sea level. Mean assuming that the water surface or sea surface is static or at still water. That's what we call it mean sea level. So the arrival times is calculated once the tsunami wave reach a coastline and reach at the level 0.5 meter from its mean sea level. That's how we define the arrival times. So that's the time that needed to travel from the source of the earthquake or source of the tsunami to reach the point where the sea surface reach 0.5 from the mean sea levels. So according to that definition, we divide the categories of tsunamis into three types. One is distant tsunami, or another terms that probably more popular is a far field tsunami. This kind of tsunami is generated very far away, so its source probably in the middle of ocean, or it will take longer than 3 hours to reach a certain point from its source. So, for example, if the earthquake occur, okay, let's take case from the 2004 Indian Ocean tsunami. I I shown to you the location of epicenter of the 2004 IoT, right? So that source, if that travel to somewhere in Sri Lanka, for example, to the eastern part of the Indian Ocean basin, it will take longer than 3 hours to reach the beach or the coastline of Sri Lanka. So, from the Sri Lankan area perspective, the 2004 IoT is considered as distant tsunami, but has a different story for us here in Aceh because the 2004 tsunami reached our beach area, our coastline, less than 1 hours. So the 2004 tsunami for the area in Aceh or along the western coast of Sumatra is called it as near field tsunami or local tsunami because it's travel shorter than 1 hour to reach the targeted coastline. And in between of that, in between distant and local, we have regional tsunami. So that's this type of tsunami will take about 1 to 3 hours to reach the targeted coastline. So the response to the types of tsunami will be probably different. Let me get back here. Suppose that if you receive a warning, right, to evacuate, um, but the arrival times of the tsunami probably less than 10 minutes, right? And compared to if you receive a tsunami warning where its arrival time probably longer than 3 hours, your response to that kind of these two tsunami obviously will be different. If less than 10 minutes, I guess a big panic will occur and probably traffic congestion will be everywhere, even traffic accident will occur. And if a tsunami happen in that kind of situation, we probably will estimate the number of human casualty will be staggering. So compared to the one that arrived longer than 3 hours, have more times to prepare yourself, to evacuate yourself, or to identify a safer place to seek shelters and everything. And even you can communicate to your family or friends to agree where to meet or to assembly. So I'm not saying the distant tsunami is going to be less deadliest, but this will result in different response of the community. Please bear in mind, 1960 Chilean earthquake and tsunami that occurred in the continent of America, in in western coast of Chile. It's traveled very far and reaching the eastern coast of Japan, and it's still deadliest and kills some people over there. Even it travels for more than 10 hours. So please bear in mind, I'm not saying we are not like encouraging people to get relaxed to the types of tsunami that is classified as distant tsunami. What we are trying to say is that we need to manage the response properly. Okay. The extreme one, of course, the local tsunami or near field tsunami. So now let's ask ourselves what kind of mitigation we can provide based on these three types of arrival times. Okay. Now, about the tsunami early warning system itself, right, the role of tsunami early warning system is first to detect is any anomaly on sea surface after large earthquake. Large earthquake is classified if the magnitude larger than 7 and it's shallow. The hypocenter of the earthquake is very shallow and occur in the ocean. So that is the first or the preliminary indication if one earthquake can potentially cause a tsunami. So the tsunami early warning system will detect if any anomaly of the sea surface occurred once a major earthquake happened in around your area. Right? Then secondly is to disseminate the result of the analysis from the detection process. If there is a confirmed tsunami, so this system will then disseminate the information with a certain levels of warning. That's depending on your countries. In Indonesia, we have 3 levels of warning for the tsunami early warning system after one major earthquake occurred. And these two steps is aimed to prevent any human casualty or losses due to impacts of tsunamis. But please be careful that tsunami early warning system does not mean to stop any wave propagation from the source. No. It also does not mean to be a tool to reduce the energy of tsunami waves. At the moment, that kind of thing is not part of tsunami early warning system, right? So there are two parts of tsunami warning system. One is detection and second one is dissemination. Now, if you receive information, right, make sure that your response to that kind of information is correct rather than panic. One can be panic or probably can be calm depending on the understanding on the risk itself. If you are if you know enough about the geographical context of your um, complex or where you stay, you probably will be much easier for you to identify where you need to run or when you need to evacuate and how many minutes that will take you to get to reach that points. If you know that kind of information, you can manage your emotion, your psychological aspect, not to be panicked, and you can evacuate orderly, in orderly manner. But if you are very Well, if you are strange to that place, you probably have a problem to identify a correct route to evacuate yourself. And you probably not sure how many minutes you need to run or to evacuate until you're sure that that is the place is a correct way, is correct point to evacuate or to seek shelters. So these two kind of comparison again confirm the need to increase disaster preparedness before the disaster event. That's why during disaster preparedness activity, we need to include how community or how the person can respond to tsunami early warning system or any disaster early warning system properly. Well, can be landslide early warning system or other kind of early warning system, of course. So, yeah. Then, all right. On the right hand side, you can see the system of tsunami early warning system that developed earlier for INATUS or Indonesia Tsunami Early Warning System, where we had a number of GPS buoys over here, yeah, that detect almost as close as possible to the potential source of undersea earthquake that can probably generate tsunami. And then it transmit to land station during using um, communication satellite, and then delivered to the land station over here, and then read and analyzed by the authority before it disseminate to uh, targeted communities. Okay, there are three part of tsunami early warning system in general. So we have upstream part where detections of tsunami send warning to national point and receive the warning by national point will be done, and then there will be interface um, section on in the system that conveying the warning, ordering evacuation, including in ordering the for evacuation. And then at the downstream part is to publicize the evacuation orders and evacuate people. So these um, a general spaces of tsunami early warning system that published by Sakala Surya in 2018, which actually almost all tsunami early warning system adopt the same base. Okay, United Nations General Assembly realized that uh, predicting and estimating or even investigating characteristic of hazard, coastal hazard, including tsunamis, very much influenced by the data themselves. If the data are good, it could have a high potentiality probability to deliver better information on the hazard itself. But if the resolution of the data is not that good, probably our understanding on the risk can be also not good. So in 2017, United Nations General Assembly proclaimed what they name it as UN Decade of Ocean Science for Sustainable Development, or called the Ocean Decade. One of the objectives of the Ocean Decade program is to provide a good data resolution from the oceans so that can be used by scientists and stakeholders to understand the characteristics of their ocean and probably also include coastal hazard. In this regard, we are talking about tsunami. Um, So based on this General Assembly meeting in 2017, UNESCO, under its Intergovernmental Oceanographic Commission, has been mandated to coordinate and to implement the Ocean Decade until 2030. So you all are younger generation. I believe some of you are going to be a scientist too. You are going to learn about how to understand characteristics of tsunamis. You will need a good data resolution. So I guess you need to explore more about the ocean decade. You can search in the Google probably to look into activities that related to the ocean decade. Now, I'm going to continue with the mitigation types in terms of tsunami evacuation buildings. In the case of Banda Aceh, this is part of the practical examples in that probably we can apply in our area. In Banda Aceh since 2005, we have 4 types of tsunami evacuation building or escape building in other terms. Type A, that's building that are aimed only for evacuation building since they were constructed. That's mean a single purpose one. And then type B is building that were aimed for multifunctional buildings, including for tsunami evacuation buildings. Type C, tsunami evacuation buildings that were initially for single purpose, like for office, and then but later changed or transformed um, also as an escape building, so it then become multifunctional building. The last one is type D, and initially there were private buildings like hotel, for example, or houses, big houses, but later modified to suit the purpose as alternative tsunami evacuation buildings. So now, in the context of Aceh, for example, right, which type of among these 4 is the most realistic for social and economic context? So the same question in your area in Japan or in other part of Indonesia, which type of the building that's suitable for your area to be function as escape building? Now, these are types A of escape building. On the left-hand side is a tsunami escape building in Banda Aceh. On the right-hand side is tsunami escape building in Labuan in Banten, not in Aceh, somewhere in Banten province of Indonesia. Both of them are single purpose because from initial start, they were aimed as an evacuation building, not for other purpose. Okay. If there are other activities in the building, actually it is not the kind of routine activities, it's just incidental. Then these are type B and type C. Type B is Aceh Tsunami Museum. Some of you from museum. Although this is a museum, this also can be function as escape building. Okay. But initially it is not for escape building, but it can also be used as escape building. So it is a multi-purpose building. On the right-hand side is type C. It is an escape building, but later changed also an office for firefighters and disaster management agency. The right-hand side, the type C, is located in West Aceh district. Now, this is type D. Both of them not actually for public use. The left-hand side is a shop, actually a private owned buildings. The right-hand side is a mosque, also not it's not like a public structure. It's owned by Muslim community. All right. But later this changed because you can access. You can see that this one is a stairway over here. Actually, was designed by disaster management agency of the district, so people can use the rooftop of the shop over here as alternative escape building instead of running away horizontally. Because this city is very flat, almost similar like Banda Aceh. You cannot um, have you cannot reach any hills around the city within at least 1 hours. So no point to run away. But if you cannot run very far, you can use just the rooftop of the shop as an alternative for the escape buildings. Similarly, with the mosque over here, so the rooftop of the mosque can also be used as escape building because there is a stairway over here. You can see this is steel stairway, so people can use reach that level to evacuate themselves. Now, the single purpose escape building are not very effective based on the latest event in 2012, where among the 6 escape building in Banda Aceh, almost all of them were deserted by the community. Almost none of the people use the escape buildings. Only one of them were used by some dozen people. But on the other hand, actually, in one time, that building should accommodate at least 800 people in one time. But only a dozen people use one building. The other 5 buildings, no one use that. But to construct a big building, you understand that it requires a lot of money, right? But it's hard for us to maintain and also to operate such kind of single purpose escape building. Now, interestingly, we observed that there are a number of mosques during the 2004 IoT can sustain a massive destructive effects of the tsunami, like the one in Loonga over here, sorry, Lampu over here, and the one in Ulele Banda Aceh over here, and one over here in Melabu. Although this is probably 1 floor, so only because of the wave height not that high, so it still can't, you can still see the roof of the mosque left. Now, my colleague conducted a survey to see the fragility of the mosques in Aceh, and then classify all of them into 5 state of damage over here. So we call it DS0, 1, 2, 3, 4. So from DS0 where no damage, only inundated, until DS4 where the building or any structure will be swept away. So you see, I'm sorry that the colors were not indicated over here, but the dark red over here indicated the largest DS4. So that's mean that the mosque were swept away because of the tsunami. But interestingly, still that we have uh, blue and yellow, where the damage minor and moderate. Means that this type of malls can be used an alternative escape building instead of constructing a large single-purpose escape building. Okay, I'm skipping this. So we can use this kind of formula also to identify which building in our city can be used an alternative tsunami escape building. So the name of the method is combination between BTV or Building Tsunami Vulnerability Assessment, and on the right hand side is a fragility curve of building. So these 2 equations can be then combined, and then we can combine with the type of the building over here. For example, TI for timber, CM for confined masonry, 1 floor, RC2 is reinforced concrete building, 2 floor, and then 2 stories. So RC3 mean reinforced concrete with 3 stories, and RC4 reinforced concrete 4-story or above. So we can use this method and then map the type of the building like this one that we did for Banda Aceh. So we measure all like almost 85,000 buildings and identify which one of them are classified to TICM, RC, and so on. And then we use the previous method. We can see which building will be left, will be remained after the tsunami. For example, this one, if the tsunami generated by the magnitude 9.2, so you see this is the distribution of the damage of the building in Banda Aceh. probably because there are too many, it's hard for you to see where the green in the middle of red, right? But I can tell you that within this red area, we found that there are 96 buildings can sustain tsunami in case of the tsunami generated by 9.2 moment magnitude. Means that among these 96 buildings, they are very high. They have high potentiality to be alternative escape buildings. They could be schools, mosques, or hotel, or um, meeting assemblies room, for example, or other kind of building. They can be changed to be alternative escape buildings. But still, our task to deal with the owner of the building, because it is not really good, right? I mean, it it take a process to deal with the owner if they can permit, if they can allow, if they allow people to use the rooftop, for example, of the building in case of tsunami happen. Whether they can permit us to construct, for example, a stairway um, at the back side or um, at one side of the building so people can reach the roof floor, the rooftop of the building. That kind of thing is that we need to still need to work on. So to end my presentation, I would like to give interlude notes. I'm not going to conclude, but rather than saying this interlude, number one, risk can be reduced by minimizing magnitude of hazard, decreasing vulnerability, and increasing capacity. That's exactly what disaster risk reduction means, right? Secondly, a sustainable disaster risk reduction is needed as part of long-term process, as tsunami may repeat itself with the very mechanism and magnitude at unknown period, like the one that I shown to you, the coastal cave in in Aceh. And then number three, SFDRR is an active global framework for disaster risk reduction until 2030. With its four priorities of action, it is expected to be aligned with Sustainable Development Goals or SDGs, right? Lastly, but not least, so Tsunami Early Warning System or TEWS is an important system to immediately inform community at risk about potential tsunami event in the area, as well as a basis for ordering people evacuation process. So that's my presentation. Now, before we start with discussion, I would like to have two or three questions, if any, or any comments from. Sorry, exactly that set my alarm over here. If you have any question, some of you, yeah, maybe I would like to give to Imam Maulana. There, okay. Imam is here on site, so I would pass this mic.
Assalamualaikum warahmatullahi wabarakatuh. First, thank you very much for Prof. Syamsidik for the knowledge sharing. What a great knowledge sharing. Here, I would like to ask about something that I found interesting. We learned that Type B and C escape building are basically a public building that the main function is not as escape building, but is like a tourism destination, like the Museum Tsunami, and also there is like mosque as the main function as the religious ritual places that being used as an alternative escape building. On the other hand, we found that the Type A escape building that mostly the main function as the escape building was being deserted, right? Uh, my question is, by this condition, is it possible to reverse the condition, the logic that we use the escape building as the public places, like a youth community activity center or the organization secretariat? So it's like the reverse logic. We use public places as escape building. Now we use escape building as a public places. Nah, thank you. That's my question. Assalamualaikum warahmatullahi wabarakatuh.
Okay, maybe I'll respond this first. I'm not sure if other probably have similar question. So, if you want to change the type A become multifunctional too, that's no longer type A, right? So that's mean either type B or type C, right? So it's initially it is single purpose, then you will also function it as multifunction. That's exactly what West Aceh district did for the escape building over there. Initially, it is for escape building, then but they also changed that become an office for firefighters and Aceh West Aceh district management disaster management agency. Um, sure, we can do that. Why not? That's the one that we suggest actually to the authority. So we need to function the single purpose escape building that already constructed to be a multifunctional building instead of single purpose building. Um, but in the future, my point is that in the future, I believe it is not a preferable way to construct a single purpose escape building anymore, looking at the case of Banda Aceh. So if you are the authority, probably the best one to start with escape building is to construct type B or type C, not type A. Because what we have seen in the case of Aceh, it's caused a lot of problem over there. Yeah, that's my response. So second question, probably from the online. Sorry if I pronounce this not correct, Mr. or Miss Ho Wing Choi. You can unmute yourself and ask the question.
Hello, sir. Thank you very much.
Um,
I'm actually in. Can you hear me?
he's already, the problem is she's already unmuted, I guess.
Yeah, but we couldn't hear your voice still.
No.
Can you hear me now?
Yeah, that's good.
Right. Thank you very much. A heartfelt thank you from. I'm actually currently in Istanbul. Thank you very much for your presentation. I actually have two very close questions. The first one is, so why are the other 5 type A escape buildings abandoned in the first place? Do we know why? And secondly, since we know there are 96, I believe, yes, 96 that can withstand tsunamis in the red zone, but they look like just any other ordinary buildings. How do we educate the residents that these are the ones you have to go to if unfortunately you're within this area and you need to run fast? Thank you.
Yep, thank you. Excellent questions. The first one, why the other 5 buildings were abandoned during 2012 event? As a good paper written by Jamie McGaughey, you can search that in International Journal of Disaster Risk Reduction. I forgot the year of the publication, but that paper reported about trust and distrust on vertical evacuation buildings in Banda Aceh. Um, among among the reason why people did not use the other 5 buildings in the town were, well, generally on distrust on the building itself, the quality and the strengths of the building, the doubts if the building can sustain the tsunamis or even the earthquake. That probably very much motivated or the background of the way they perceive on the tsunami vertical evacuation building based on um, probably previous experiences that they encounter with the structures quality of the building in Aceh, especially public buildings. That's number one. Number two is they in normal day they did not see any people use that building. So building keep empty almost all the time. So emotionally and psychologically, that function, that building is far from them, right? So in their mind, if they have to run to save their lives, that building is not the thought in their mind. It's not very close to their heart. So instinctively, I guess everyone will run away horizontally instead of going up to a building that you are not familiar with. Well, I would probably ask to all of you, if you are given two choices to run to evacuate from tsunami, one is a building and another one is a hill with the same height and same distance, which one that you are preferred? I guess same with me, I will go to the hill. Why? Not to the building. I guess this one is the trust issue. It is a trust issue that we need to manage. Stairs that this outside building that can suitable for public people that even they don't know what the building or familiar what the building. Yeah, yeah. Of people that even if I have that condition, I will choose the building that higher that accessible, so I can go to top. Yes. That's the other that one thing that why actually we encourage to have a multifunction building instead of single purpose. Because in normal day you will not see anyone use that building, and well, why you have to save your lives right to that building. You probably, even in Aceh, in the context of Aceh, the people prefer to run to the mosque, right? To the mosque, because they prefer, if they have to die, they think they are going to die, they prefer to die in the mosque instead of other building like escape building, which is actually no one over there. So this is kind of lack of familiarizations of the function of the building function. So what we need to do actually to raise awareness of the community of the building and encourage to change those single purpose building become multi-purpose building. Okay. Now, the second question, um, how do we know that people can run to that 96 building that I indicated earlier? Well, this work has not been completed yet. But I assume that once we agree with the 96 building in this city can be alternative escape buildings, first, number one, we need to make a meeting or agreement with the owner of all the buildings. If probably not, some of them are probably don't agree their building to be function also as a escape building. But if they agree their building to be used also as an escape building, secondly, we need also to ensure the strength of the building itself, and also to check the facility in the building if that can be accessible to all people to reach the highest level of the building. Okay. Number three, we need to put a mark over there, yeah, stating that this building can be functioned as an escape building. Of course, we need a map. But map, of course, that's very static. We can change also to online, so people can develop that in apps, for example. So that's you guys, the younger generation. You can develop in apps, so people can identify which one is an alternative escape building in the town. Yeah, instead of having a printed map like this, I'm not sure everyone will carry that every time, everywhere. That's not a very practical way. Again, this is a practical examples of how we can mitigate the impacts of tsunami. Yes.
Like you said before,
type B and C is preferable more than D or D. Yeah? But I have another idea about how we can apply type D building to recommend the government, the authority, if someone who's wanna build the building more like for apa istilah higher minimum 3 lantai. So a third floor. So they have to make some emergency stairs that can accessible to public people. That's we can recommend that the government. That's all what the concrete, yeah, concrete. So the government can uh, make a rule to the owner. That's concrete. If my opinion, right? Thank you.
Yeah, it's an excellent idea actually. So I agree if we can probably ask the government to impose a kind of regulation to ask or to require the owner of the building, those buildings are higher than 2 floor or 3 floors, to provide a stairway at the side of the building so people can access the building. But again, this is not a straightforward problem. Okay, we need to deal with a lot of issues economically because if a building is a private owned buildings, okay, um, the government cannot just mandate or urge people to give a stairway to reach the rooftop of their buildings, because the owners still have a concern on the safety of their building. Probably their staff or robbery can also reach the inside their property easily, even if they construct a stairway. So that's why what the disaster management agency did, like I shown earlier. Can I show the slide again? Yeah, this one. It seems like easy and simple ID, but I guess this is excellent ID too, because yeah, it's provide this stairway over here so people can use the rooftop of this shop to be as an alternative escape building. It looked like very simple, right? But the process that reached to this point require a lot of discussion, focus group discussion, even some arguments with the owners, and some you know yeah, a lot of arguments happen, because they will ask, well, so what will I get if I construct this kind of building? Will that affect the strengths of my shop? Will even theft, the thief can easily enter my shop? What happened to, are you going to secure my property inside if something happens? So there are a lot of questions. So what I'm trying to say is, even this kind of, with this rather simple form of escape building, still we need to do a lot of things to convince the owner so they agree with the having a stairway at the back of, at the side of the shop. So that's yeah, but your idea is good. So, but believe me, it's not like straightforward. So we need to deal with several issues too. Okay, I'm not sure. Do I have still time? No, no. Okay.
For the answer the question, yeah.
Okay, now, okay, sorry. Sorry for the question and answer. We close the session. If you still have a question, you can just email me, or we have a group, right?
We have a good.
You can even ask the question in the WhatsApp group, so I will respond it later on. But we will now enter a group discussion. We will, can you show the slide again, please? Yeah, we have 3 questions to be discussed, but we will divide the group into two, this class into two groups. So each group will appoint one person as coordinator who moderate the discussion and conclude the discussion, and then assign one person to take note of during the discussion. Okay, we have 3 points to be discussed. So, but each of group will discuss different points. Number one, what do you think about tsunami risk reduction? How tsunami risk reduction can be done in your area? Okay, you come from different places, so please come up with any story you have from your area. Number two, do you think youth organization or young generation have a better understanding towards tsunami risk now than before? What I mean than before is, yeah, probably before 2004, before the 2011 gadget. And please elaborate further your answer. And lastly, in recent years, electronic media, especially social media, have been widely accessible and popular. How these media can be utilized as channels to increase community awareness towards tsunami hazard. Okay, right. Now, point one, sorry. Point one is supposed to be discussed by one group, and point two and three to be discussed by group two. So that's the way I think point two and three, you know, you will have probably similar amount of length. The length of the explanation will be similar to the point one. So that's why we divided into two section. Now, for having the group, I share this one. No? Yeah. They can see this. Okay. So you see that there are two groups over here. If you see your name in group one, so please join the breakout room number one. And then if you see your name in group two, please join the breakout room number two. Then, yeah, you can start discussion by selecting one person to be a coordinator and a note taker. You will have about 15 minutes to finish all the discussion and the note taking. And then we will have about 5 to 10 minutes to report. So you will return to the, you will exit from the breakout room to normal room. Is it normal room? The main room, sorry. The main room. So that's the way how we are going to do this. So I would like to let Dr. Haikal Azharidi probably to further process.
Yeah, I think just take forward. You guys can go to the bottom panel of your Zoom. You have the breakout rooms, and then please choose the one that we already assigned. Where is your name, and then which group that or which breakout room that you need to join. So as soon as you got into the breakout rooms, uh, the committees and the operator will be there to help you, and then you can start the discussion. Just like Prof. Syamsidik said earlier, you need to choose the leader and then one note taker and then start the discussion within the group. So go ahead. If you have any difficulties, just let us know and then we can assign you to your room. Thank you very much. You have 15 minutes for discussions.
Okay, here I would like to present our discussion regarding our public. Okay, for the first question is about how the impact tsunami on our community, right? So actually in 2004, our community, especially in Aceh, we hardly ever heard about the tsunami itself. So it created a big impact in our community. After the 2000, sorry, after 2004 earthquake, our community learns much more about the tsunami itself, and it's the knowledge is growing by itself. Therefore, we believe that the tsunami risk reduction should be done not only considering as part of the education, but we also must consider the characteristic of the people. And also, we realize that every people or civilization have indigenous knowledge, like Smong in the Semelu. So we can use this kind of indigenous knowledge to make sure we can effectively increase the disaster reduction, especially tsunami. And also, the education system regarding the disaster reduction or tsunami should be comprehensive, inclusive, and also gender-based. Nah, the approach that we can start from individual and also to the family and then the community, and make sure that the approach that we do is based on the local context and the level of the risk itself. Nah, we realize that in order to in order to decrease the risks, we can decrease the hazard or the vulnerability or increase the capacity, right? Now, we tend to think that it's better for us to increasing the capacity regarding the tsunami itself. So therefore, capacity building in order to raise disaster awareness, so education and communication is demanding. And also, we might consider in Aceh itself, this is a tourism spot. So when we do like a drill, we need to consider what it impacts to the local tourists, based on the lesson learned that Olivia told us that we can learn from the fear experience, and also uh, consider the language barrier, because in Aceh, there are also tourists that come here, especially in the end of the year, like when we do the annual celebration for the uh, IoT, right? And also, we can suggest to the government to provide evacuation roads. And here we would like to share that sorry, yeah, the youth organization and the younger generation and also the media itself is really impactful in order to is a potential in order to increase the disaster reduction, especially in tsunami itself. Uh, because the media right now, it can be used as the channel for uh, disseminating the knowledge itself. Nah, so the youth empowerment or the youth participation in order to increase or sharing the knowledge itself, it's crucial in our places in Aceh. One other thing that uh, we know that the youth is the one that use social media like a lot, right? Rather than the older people, and they tend to use this media social to show what they are doing, right? Nah, we think that is if we can use the escape building, we can multi-purpose escape building. We can do like food festival in escape building. We can do like bazaar or like another activities in escape building. They will share it to other people, so the people will know that the escape building is actively. They can come to the escape building. They know this is a place that not only can be used as the safe place, but also for the activity of empowerment. And also, as we know that uh, there is an increment of your organization, especially in disaster reduction. But the problem is this youth community, they don't have any secretariat, they don't have any place to do their activity. So providing these buildings as their activity places, it will surely they will record, they will share it to their media social. So that's all for our discussion. There's so many opinion for other people. It's hard to sum up, but I sorry if there is a lot of things that missing in our discussion. And thank you.
Yeah, very nice. Giving back to Prof. Syamsidik.
Thank you a lot for the group A, group one, for delivering the conclusion from your group. I will not comment, I guess, after I will wait for the group two first to elaborate the conclusion before I comment in general. So now I would like to invite the spokesperson from group two, either coordinator or someone.
Okay, sir. My name is Pierre. I'm going to be the speaker.
Okay, yes, please go ahead.
Okay, so allow me to share the screen, and to friends from group two, please allow me to present our ideas. So we're going to present our answers for the second and third questions. So for the second question, we have come to 5 points of conclusions. Firstly is that surely information nowadays are easier to be accessed because the term of before and after here that we use is before media and after media. And with the ease of media usage, information is surely easier to be accessed. But there are some points that we need to put more attention to. The first one is that more understanding needs to be provided. What kind of understanding? So it's more into the understanding of basic concepts in disaster, because to actually understand the disaster risk reduction, we firstly need to understand about disaster itself, maybe the terminologies and other things. The second one is, despite having an ease to access media, we actually need to lower the taking technology for granted mentality, because maybe kids nowadays can actually access media easily, but most of them doesn't actually utilize media for something purposeful for them, such as education about DRR. So we actually need to put more awareness toward these people so that they can actually utilize medias for something more purposeful, including educating themselves about DRR. The third one is that there's still an education or technology or information gap in some areas. And we can actually try to tackle these issues with contextualized methods, of course. And the fourth one is that we also need reliable sources. Maybe we can gain data from BMKG and other formal institutions so that the informations that is served are not hoax. And the last one is DRR needs to be included in the education curriculum. So it's inspired from the previous presentation of Professor Anawat, where his children are already gaining education about DRR since he was little, so that we can also actually apply the same thing in Indonesia, so that DRR is actually something that has already been taught since the beginning. And for the third question, our conclusions are that electronic media can actually be utilized to increase communities' awareness. Firstly, we have to conduct a research first using data from SNS so that we can actually know what is actually the social media trend right now. Maybe we have to educate through TikTok videos, or maybe we should use Instagram or any sort of medias so that our engagement can actually be optimized. And the second one is that, again, we have to use data from reliable sources. But before we actually use their data, we can actually also encourage these national agencies to actually create their own, let's say, propaganda, so that these formal institutions themselves can take part in educating the people. And the third one is that we can still collaborate to spread the information, so that despite having formal institutions giving the education, youth organizations or youth movements can actually also take part in the education part. And we can actually gain more engagement, of course, if we were to collaborate, because let's say I have 100 followers and my friend has another 100 followers. If we collaborate, we can actually engage to 200 followers, right? And the last one is that we have to utilize other available medias. Because there are many areas that doesn't have the same technology as the others, so that we can actually apply contextualized media. Let's say in area B, they cannot access internet just yet. Maybe we can approach them through directly educating through the school that is within the areas, or any other contextualized education that we can conduct. I think that is from group 2. Thank you very much.
Excellent. Thank you so much for sharing also the conclusion from group two. I myself learned a lot from the discussion that you conducted at both of in the groups. but I would like to highlight some points that you raised in Group 1 and Group 2. Number one, about the use of local and indigenous knowledge for disaster risk reductions. This is very relevant, not only in the context of Indonesia, but also in the context of Japan. Japan have applied so many local and indigenous knowledge in the disaster risk reductions, and not only in tsunami, but also in other types of disasters. For example, in river to combat flood and landslide and so on. So don't think about local and indigenous knowledge only is only relevant to poor countries or poor community or isolated community. That's not true. So local and indigenous knowledge still relevant to all types of community, but still we need to contextualize the use of the local indigenous knowledge. Even for one types of local indigenous knowledge, for example, smog. We heard that a lot about smog, but how then can be utilized and popularized for recent generation? Are we going to repeat what our ancestors or our grandfathers did to disseminate about the smog for nowadays generation? Probably we need to modify a little bit, but the message still can be conveyed to younger generation. Um, Secondly, I like the terms about we are humans that tends to learn from fear. Yes, exactly. We learn a lot of things from fear, but please make sure don't create the fear itself in yours. So be wise to anticipate or to think about fear itself. And I'm interested also to comment about what Group 2 also highlight the use of AI or recent um, technology in social media to disseminate and to also increase the awareness of community towards disaster, especially in tsunami context. So I think it is time for you, all of you, to explore and also to expand your capacity to do research or to use technology in order to increase the awareness of yourself, your family, and your community. So that's my comments, general comments to both of the group. Thank you so much for having a very fruitful and interesting discussion. This is my last session for today. I don't have specific conclusions to the session that we have delivered from session 1, 2, and 3 for today. But if you have any comment or questions to this module, you can just text in your WhatsApp group that's shared already by Dr. Haikal to all of you. I will also reply and also comment what you highlighted in the group. So I think that's time for me to leave the group. So now I will leave this forum to Dr. Haikal to continue. Probably that will be evaluation, right? Yeah. Right. So thank you for today. Have a good day, everyone. So Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. I know you guys just like, oh wow, it's already here. It's close to 4 p.m. So I'm pretty sure that in Japanese it's already like 6 p.m. It's close to your dinner already. So I don't know about Chow in Turkey. Should be in the morning. So okay. Very nice discussion. A very nice group that I've been walked around in group 1, group 2, and then the conclusion by both group, and then the final conclusion by Prof. Syamsidik. I would like to thanks again, Prof. Syamsidik, for the very nice discussions. For the end of the session of the day 1 of the training. Now we have a little bit evaluation need to be held on. I will ask help from the operator to send the link to the chat room. So you can go through your chat room, and then there is a link for evaluation today. So I know this is the first day already, and then for tomorrow schedule, it will be on time. We will start at 10 o'clock Western Indonesia time, or plus 2 hours for Japanese Standard Time. So please keep in mind that we have the housekeeping rules for the hybrid training. Need to make sure that you will attend the training. For the online participant, need to join the training as on schedule, as well as the on-site participant need to be in this room for tomorrow. So I hope to see you again, and please fill in the feedback link for today. Uh, and please just let us know. Some of you have do not have the opportunity to raise your questions. It's very limited time when the session's been going on. You still have the WhatsApp group. You can just post your question, and then we can deliver that to the mentors, and they will answer it, and then we will post again on the WhatsApp group. Just keep communicating on the WhatsApp group, and just let us know if you guys have anything, any thought about the training. And okay, so Pak Adito, amazing lectures, especially I enjoy the group discussion and presentation. I'm too, Pak Adito. I'm pretty surprised that they just work amazingly. And tomorrow we'll be using the same link. Yes, we will be using the same link all the way until the end of the hybrid training. So we keep using this link, and within each module, they probably have another group meeting and some other way on doing the discussions. Okay, so I do think that everyone already filled in the evaluations. So please stay healthy, and please apologize if there are any shortcoming from the committee. And we hope to see you again tomorrow. I will end up the first day of training. Thank you very much. Very productive today, but I think we should take a group photo again for the end of the first sessions. Could anyone turn on your camera? Okay, so I will ask the committee member to take the photo for the on-site. You guys facing your own laptop, or you want to face the camera there? Okay, so we can face the camera there because we are on the side, and then other that online, yeah, it's already turned on all of their cameras ready. Okay, operator, please take the picture. Okay, in Indonesia we said salam tangguh. Tangguh ya, tangguh ya. Ini ya. Tangguh aja ya kata salamnya. Okay, we said it tangguh. Okay. Please take a picture again. Okay, do we got it? Very nice. Okay, so very nice, productive first day. We'll see you again on the second day. Please stay healthy, and I will conclude for today. Wassalamualaikum warahmatullahi wabarakatuh.